Today's video will be covering the Mixing It Up lab for our Mixtures and Solutions unit. In this lab, we're going to be testing the dissolve rate of sugar in water. We're going to do multiple trials, meaning we're going to do the same experiment multiple times. And every time we do the experiment, we're going to change one variable. So in science, in an experiment, whenever you do multiple trials or you're repeating the same experiment over and over again, it's very important that everything stays the exact same. If you're using 50 milliliters of water, every time you do that experiment, you have to use 50 milliliters of water. If you're keeping at a certain temperature, every experiment after that has to be at the correct temperature. So whenever you're doing scientific trials or whenever you're repeating a scientific experiment over and over and over, you keep everything the same, and every time you redo the trial, you only change one thing. So all of the aspects of the experiment that you keep the same are called constants, because those values or those amounts will stay constant through the entire experiment. The opposite of that is the one thing that you would change for every experiment. And in the Mixing It Up lab, we'll be changing one thing every time we do a different trial. So in science, whenever you are, in experiments, whenever you are doing multiple trials, the one aspect of your experiment that you change per trial is called the variable, right? To vary, V-A-R-Y, to vary means to change or to be different. So the weather varies from day to day. Your mood can vary from day to day. What you eat varies from day to day, right? What we eat changes day to day. So in science, in experiments, when you're doing multiple trials of the same experiment, you want your constants to remain the same and you want your variable to change between trials. So for our experiment, the constants that we are using, we'll be using 50 milliliters of water every time. So that's a constant. We will be using 1 sugar cube every time, so that is a constant. The room temperature, the temperature of the water, will be a constant. So things that don't change between trials are constants. The one thing that we do change between every trial is the variable, and I will let you know what those are for each of the trials. So once again, let's get ready to test the dissolve rate of sugar in water. And if we adjust our focus down here, we can see we have our lab pages set up. All right. So first thing we're going to do is we are going to take 50 milliliters of water by using our syringe. I'm sorry, I'll let you see me do this. So we're going to take 50 milliliters of water. So that was 35, so I need an extra 15 milliliters to get to 50. Okay, now we are going to place a sugar cube in here. 1 cube of sugar. We're going to drop it in and we are going to time it for 2 minutes. And during that 2 minutes, we are going to record our observations of sugar cube in water. Now, this is room temperature water. We are not going to do anything special to this water. It's room temperature. It's 50 milliliters. Nothing is changing. And this is going to be our first trial. So I'll drop it in and start the timer. Okay. So what are we observing? Well, first off, did the sugar cube sink or float? It sank. So what does that tell us about what observation can we make about the density of our cube? All right, not seeing a lot of movement yet. Let's do it like this. Let's come down. That's a little better. Let's get into focus. There we go. Okay. Now, what we're observing here, we can see some particles coming off the top, floating up. More observations up. You just see that. It looks like our shape is changing, right? The structure of our cube is deteriorating. You can watch these particles falling off. All right, it's dusting apart. We're 1 minute and 10 seconds in, so we got about 50 more seconds of observations. Our dissolving is speeding up, right? We're seeing more particles floating off the top, so our sugar cube is dissolving faster and faster. The longer it's in water, it is falling apart. The sugar cube is breaking down. All of these are great observations you can write. We see bubbles coming off. It's really breaking down. We're at 1 minute 35. Our cube is almost all the way gone. All we have is what looks like a pile of sugar down here. We're at 1 minute 45, so this is probably 2 minutes is almost up. Okay, so we just made a lot of observations here, right? We saw it breaking down. We saw particles floating up from the sugar. We saw pieces of the sugar cube falling down into the water. It was dissolving faster the longer it was in water, which is a very important observation to record. Very good. All right, so after 2 minutes, let's make another observation. After 2 minutes, how much do we have left? Not that much. See all that cloud, all this cloudy down here, that's all leftover sugar. And even right here, what that clump is, yep, you can see that's still a piece of the actual cube still clumped together. So, good bit of dissolving. All right. So, for number 1, you can record the observations that we made. Feel free to go back and rewind the video if you need to. All right, let's talk about this one. Number 2, what properties of the water changed as the sugar cube dissolved in it? Well, first off, we started out with just normal water. Now that we have dissolved sugar into it, this is no longer regular water. This is a new substance. This is now a sugar and water solution. So we have a new property, or we have a new substance. So what properties of the water changed as the sugar cube dissolved in it? Well, first off, we got a new substance, or a new solution of sugar water. I'm sorry, down on this one. We got a new solution of sugar water. We saw, so that is what changed. What properties of the water stayed the same? Well, it's still pretty clear, and our amount stayed the same. So it is still clear, right? Even though we can see a little dust in there, we can see it's clear wherever the sugar has dissolved. So properties of the water that, I'm sorry, right here. Properties of the water that stayed the same is it is still clear, and we still have the same amount. We still have 50 milliliters of water. Moving down to number 3. What properties of the sugar cube changed as it dissolved in the water? Well, it definitely changed shape, right? So it changed shape. It changed size, right? We have much, much less sugar cube now than we did. Our sugar cube is in a different shape. What properties of the sugar cube stayed the same? Well, our color stayed the same for sure. Our color definitely stayed the same, but I think that's about it because most of the sugar cube is gone. I'm moving through this pretty quick. Feel free to pause the video at any time to rewind it and get any of this information that we have down here. Back it up as many times as you need to. All right, let's go move on to number 4. We're going to record your observations below during 2 minutes of stirring a cube in the water. So here we go. Let's position this back down. All right, my water. let's get 50 milliliters. That's 35. And another 15 will give us 50. Remember, because we are keeping the amount of water the same. So using 50 milliliters of water, we used 50 milliliters the first time. We're using 50 milliliters of water the second time. So that is a constant. The same amount of water between trials is a constant. We are using 1 sugar cube the first time. We're using 1 sugar cube the second time. So the amount of sugar we're using is also a constant. The variable for this trial of the experiment is that we will be stirring for 2 minutes. So the variable is we are creating motion, or we are creating kinetic energy. So we'll drop it in and start timing for 2 minutes. During that time, don't forget you can record your observations on number 4, and I'll be making observations as we go along. So cube, timer, and stirring. We'll stir for about 20 seconds, and then we'll stop and look at it. All right, let's stop and make some observations. Well, what do we notice? Is it dissolving more or less than the first one? Is it dissolving faster? Well, let's make observations. We can see that the edge is deteriorating. We can see our shape is slightly changing. We can see particles coming off the top. All right, we're going to keep stirring. We're at 35 seconds. I'm sorry, 45 seconds. All right, we're at 1 minute. All right, so observations again. We have even less of our sugar cube intact, so more of it's dissolving away. Our shape is changing. We are seeing increased dissolve rate, so you can see it's dissolving faster by all the pieces drifting up off of it and falling down. We'll continue stirring. Got about 30 seconds left before our timer's up, so we'll just stir for the last bit. About 15 seconds. Okay. Now, 2 minutes are up. What are our observations? Well, what do you see? We can see we have very little sugar left. It is in one small clump right there. We can see pieces coming up off of it. It's still intact a little bit, but there's still plenty of it we'll look at it from a different viewpoint now. All right, so see, we can still see a little bit in here, right there. That's a small clump of it that's left still. All right, let's record our observations. So we're on 4. Record your observations below during the 2 minutes of stirring a whole sugar cube in water. Well, we observed that the sugar dissolved, the water particles moved a lot, the shape changed. Anything you observe, feel free to back up that video and record any observations during that 2 minutes of what you saw. Particles going up or down, whatever else you can see. All right, number 5. Compare your observations of how the sugar cube dissolved in both of these trials. Both of these trials meaning the first one without stirring and the second one with stirring that we just did. So compare your observations of these two trials. Was there a difference in how much of the sugar cube dissolved? Why do you think this is true? There was definitely a difference of how much sugar dissolved in those 2 minutes. Stirring dissolved much more. See how little sugar there is left in this cup? Whereas we can still look, if we look at the first cup, right, this one, our first trial, still has more sugar in it, even though it's been sitting still, and even though the sugar had a longer chance to dissolve, this one we didn't stir still has more sugar in it than the one that we did. All right. Now let's go to, all right. So was there a difference in how much of the sugar cube dissolved? Yes. Why do you think this is true? Well, what is the only thing we changed between that first trial to the second trial? They were both 50 milliliters of water. They both had 1 sugar cube. They both had room temperature water. The only difference was we stirred it. So why do you think it is true that the second trial dissolved more sugar than the first? Well, it's pretty obvious, because the only thing that we changed about those experiments was the stirring. All right, moving on to number 6. All right, observe a crush cube. So we're moving on to our next trial here. Let me get our cups fixed up. All right, so new cup. Let's get our, all right, so the variable we are changing this time, what we are doing different, is we are crushing the sugar cube before we try to dissolve it. Well, let me show y'all. I want to show y'all the mortar pedestals. We'll do it this way. All right, so let's add our 50 milliliters of water real quick. Okay. Now, the way that we, hold on one second, grab a supply. Sorry about that. I was missing a very important tool for any scientist or alchemist or apothecarian or natural healer. This is a mortar and pestle. Basically, it is used for grinding, pulverizing, or crushing herbs and substances. These have been used for thousands of years to help make healing salves or potions or medicines. They're really good for grinding herbs, and grinding herbs can help give us different properties out of it, right? So a crushed up substance might have different properties than a whole substance, and we're about to learn a little bit about that right now. So the variable for this trial is that we are crushing the cube, okay? It's not going to be one whole cube. We're going to crush down into small bits. So the variable that we are changing is the particle size and shape of our sugar cube. So here we go. We're going to knock it out. Sorry if that's loud on the computer. See, we're just crushing this into smaller pieces. If it sounds like this is very satisfying, that's because it is. It's actually very cool. I like using mortar pedestals. Alright, so we're just grinding it away, turning these particle sizes into much, much, much smaller. I could keep grinding, and it would keep getting smaller and smaller. But we're going to move ahead. Now, remember, the only thing we are changing is our particle size. So our variable is our particle size. Here we go. So we're not going to stir. Room temperature water, 50 milliliters of water. All those are constant. The only variable we are changing is the size of our particles. So y'all watch this and make observations and answer number 6 for 2 minutes. All right, so what observations are we making? Well, you can, if you look closely, you can see that it is dissolving, right? We can see the little faint, if I get a little closer, it might get out of focus. That's not bad. We can see the faint particles rising up. Okay, you see those coming up, so it is dissolving. The crazy thing is, I know it looks like it didn't do much, but if we look in here, there is practically we're only a minute and 10 seconds in, and there's practically no sugar left in here. It has dissolved so fast, it was almost immediate. There is still some sugar on the bottom. I'll kind of swirl it around, see if we can get it in the middle. Right, you see that small, faint clump of sugar right here in the middle? That is by far the least amount of sugar we have had in all of our trials. So, we're a minute 37 seconds in. I'm not even going to finish the timer because this is pretty much done dissolving. It will dissolve a little bit, the rest of it will dissolve slowly, but we can move ahead because I think we get the idea. So, number 6. How did observe the crushed cube in water for 2 minutes? Record your observations below. Well, what did we observe? We observed it dissolved almost immediately. We observed there is very little left, and we observed that it did not take very long for all of that to dissolve.
I found this on the web.
Number 7, compare your observations of how the sugar cube dissolved when it was whole and when it was crushed. So, was there a difference in how much of the sugar cube dissolved? Absolutely, there was a difference from the very first sugar cube that we dissolved compared to this one that we crushed up. Was there a difference in how much of the sugar dissolved? 100% there was. So why do you think this is true? Why do you think this crushed up sugar cube dissolved so much quicker? I'll let you pause and answer that. When you're finished, hit play and we'll move on to number 8. All right, number 8 is our final one. We have to use some hot water for number 8, so let me get that warmed up for us. Number 8, we're doing the same thing. 50 milliliters of water, 1 sugar cube. We are not stirring, so all those are constants, right? Our constants is 1 sugar cube, normal size, 50 milliliters of water, normal amount, and we are not stirring. So the difference is, the variable is that we are going to use warm water. Warm water. So sit tight while my water warms up. Go ahead and finish answering number 6 and number 7. We'll get started in just a moment. All right, I have our electric tea kettle here. We are going to add about 50 milliliters of water. Might be a little. All right, let's put this down here. And for a final time, let's do our last trial. Remember, all of the constants are the same. The variable this time is we are using warm water. All right, so answering number 8. Observe the sugar cube in warm water for 2 minutes. Record your observations. So what do we observe? It is already doing what? It is already dissolving. Look at that. We have a lot of deterioration on this side. Look at all that. Man, it's breaking down super fast. Look at all the particles floating up. Look at all the particles falling down. It's just disassembling, crumbling. Crumbling. Wow. Remember, the variable here is warm water, so we change the temperature. That's what's causing this, is the change in temperature. We are 45 seconds in. It's demolished. Yep, coming apart, coming apart. I'm going to let you watch the rest from the top here so we can see the amount of sugar. There is practically nothing left. All right, just a tiny little bit over here, a little bit right there. Let's see if I can swirl it. I'll get it in the middle. Kind of collect it there so we can see it. Yep, that's all that's left. Right there. All right, so number 8. What did we observe in warm water for 2 minutes? And it's still only 1:30. So this went way fast. So it dissolved very quickly. It started breaking down immediately. Particles in the water were coming off the sugar cube at a much, much faster rate. Number 9, compare your observations of how the whole sugar cube dissolved in room temperature water and warm water. So we're comparing the first trial to this trial, right? Was there a difference? Well, you tell me. Was there a difference in how fast the sugar cubes dissolved? Was there a difference in how much of the sugar dissolved in 2 minutes? Was there a difference in how quickly the particles moved in the water? All right, get those answered. And then number 10, what conclusions can you draw about how shape, temperature, and stirring affect the dissolving rate of a sugar cube? Well, how did shape affect it? Think about trial 2. How did we change the shape? Right, we used these tools, a mortar and pestle, to change the shape from a cube to tiny little bits. So we changed the shape and the particle size. And how did that affect the dissolve rate? All right, we changed the temperature when we heated the water up. How did that change the dissolve rate? And lastly, during the second trial, we stirred the water instead of just letting it sit. So when we stirred the water, how did that change the dissolve rate of that sugar cube? So once you finish answering those, that is all the information. And now I want to take a brief second just to talk to you about why the sugar dissolved faster with some of our variables. So we can safely say that the sugar dissolved the slowest when it was room temperature water, we weren't stirring, and it was in a cube, right? The very first trial we did. That was when it dissolved the slowest. So, that one. So, now what we want to do is talk about why that is. Now, here we have let's say this is our sugar cube, okay? When we did our first trial and put this sugar cube in water, the water started dissolving the cube all at the same time. Whatever the water touched began dissolving away. So, as soon as we dropped this in the water started dissolving the top, the sides, the front, the back, and the bottom. It did not dissolve anything in the middle because the water couldn't get there. To get to what's in the middle of this cube, the water had to slowly dissolve away one piece, and then it could start dissolving what's in the middle. And once it dissolved and broke this piece off, now it can start dissolving on these newly exposed sides that it previously wasn't able to get to. So why does this change whenever we add in variables? Well, water molecules are always moving, even if they look like they're still. So as we drop this first cube in the water and let it just sit there, even though the water is being still, the molecules are slowly bumping and rubbing against these walls, and it takes a little bit of time for the movement in the molecules to separate the molecules of the sugar. Now we can change that by making the water molecules move faster. So when we were stirring, the water molecules were moving faster. So the water molecules were hitting against the edge of these much, much quicker and much more often. So it was able to break them apart just because it was hitting them constantly, making them come apart. So then it could start working at new areas that it wasn't able to get to as fast in previous trials. When we crushed it, right, we didn't have this particle size or shape. When we crushed it, we broke our sugar cube down into individual particles. That went so much quicker because the water did not have to dissolve all the sides before it could start dissolving in the middle. Once we had broken it down, the water was able to dissolve all sides of this piece at the exact same time that it was dissolving all sides of this particle, along with all the sides of this particle and this one and all of this one and all of this one at the same time, as all of this one at the same time and all of this one at the same time. When we broke it into smaller individual grains, the water was able to dissolve and the molecules were eating away at each individual particle at once, rather than when it was a cube and they had to slowly pull the layers back. And with the heat, heat is interesting because it goes back to movement. Remember, heat energy makes molecules move. The molecules in this table right now, even though we can't touch it, even though we can't feel it, the molecules in the desk or the table that you're sitting at, even if it feels completely still, all of these molecules are vibrating and they're moving. Even if it's sitting still, they're still vibrating. As we give heat energy to something, or as something gains heat, or as it gets hot, the molecules in something that is heating up start vibrating more and more and more and more. So if we were to heat this table up, not set it on fire, but if we were to heat this table up, even though we couldn't feel it, as this table got hot, these molecules were heating up and they were gaining energy and they were moving a lot more. So what happened when we had the hot water is when we put our cube in it. Remember we talked about when we stirred the water, the water molecules were hitting the cube at a much higher rate and much more frequently. So they were chipping away at the sugar particles because they were moving around it. Well, the hot water basically does the same thing without us having to actually stir. Because the water was hot, the molecules were vibrating and they were moving. So as soon as those vibrating molecules got around the cube, even though the water wasn't moving, the molecules were moving. And so the molecules were very quickly just beating away the edges and the grains of these of this sugar cube, so that the heated water molecules were moving so quickly that it just immediately started tearing away at our sugar cube. All right, man, that's it, guys. That is our Mixing It Up lab. Important information to take away from this, right? If we want something to dissolve faster, what can we do? We can change the shape, make it in smaller pieces. We can stir it to get the water molecules moving, or we can heat up the solvent, right? We can heat up the solvent. That also reminds me, don't forget, at the very top, we did not go over this because I want you to do that yourself. This is information that you should be able to answer. You can either give me an example of a solvent and a solute, or you can give me the definition of a solvent and a solute. I'll take either one. All right. Thanks, guys. See ya.